Good day, welcome to this lecture video. So this video is about tests for one sample, particularly a non-parametric statistical test called Binomial Test of Proportion. So what is a binomial test of proportion? So it is used to determine if the population proportion of one level in a binary or dichotomous variables equals a specific claimed value or the hypothesized value. So here are the hypotheses if we are going to use binomial. So first, of course, the population proportion of our one outcome equals some claimed value, or our alternative is, of course, the population proportion of one outcome equals some claimed value. So which means it's not equal. And for the assumptions, we of course need to make sure that our variables are randomly selected. So we have a random samples and that the observations are independent, that the variable of interest is binary or, which means that we have two possible outcomes only. So if you can still recall, we have finished discussing the t-test for one sample, but that particular test is used for mean. So the binomial is also t-test for one sample, but of course it's not telling us that we're going to use the mean, but rather since it's emphasized here that it's proportion, so our focus is proportion. And the number of trials, n is fixed ahead of time. Okay, so we have here an example. So for example, a restaurant is launching a new menu. So we have menu spaghetti. So the new spaghetti is also known as longanisa pasta, and the traditional is of course using pork. So in doing this experiment, 30 customers will be asked about their preference. So first, we have to check if we met the assumptions, like in assumption number 1. So we have to make sure that we have a dichotomous response variable or binary variable. So we can use, for example, that 1 corresponds to the new menu and 2 corresponds to the traditional. For assumption number 2, the outcome of each trial can be specified as a success or a failure. So we need also to classify what is our success here. So are we telling that the success, for example, is the longanisa pasta because this is the new menu, or of course it can also be traditional. Anyway, we can set that in the SPSS. And then assumption number 3, the probability of a success, it's denoted by P, remains constant from trial to trial. So for example, a respondent can choose between 2 options in a series of trials, but they cannot have 3 options in some trials and only 2 options in other trials. Well, for assumption number 4, the N trials are independent. So we already mentioned this a while back. So this means that the one trial cannot affect the result of another trial. For example, getting feedback from each trial might influence the following trial. And number 5, the sample you have collected is representative of the population. So you have used simple random sampling. Okay, so aside from, of course, considering binomial rather, we also need to consider the Clopper-Pearson interval, which we're going to also use at the same time, or this is also called exact interval. It is an alternative to calculate binomial confidence interval using normal approximation. It is based on inverting the equal-tailed binomial test. It is the most commonly cited exact method for finding a confidence interval. So in a little while, we are going also to explain the output that we can generate using the Clopper-Pearson interval. So here are the reference materials. So of course, to do this and to better understand what we are talking about this test is we're going to show a demonstration using SPSS. Okay, so let us consider, of course, doing the test. So we have here a data. So here is our data. So it is, of course, the preference menu. So as mentioned, we have 30 randomly selected customers. So one corresponds here. So we can check it in our variable view that one corresponds to new and two corresponds to traditional. I use one for new because the default in using the test is the success is always the first number or the first code that we used. Okay, so this is now the meaning of one. So it's the new, it's the longanisa pasta, while two is the traditional using pork as is. And for the data view, of course, we have here the 30 responses from our respondents. So what are we going to do? So to locate, of course, we have a binary because we have two options only, and we also set here that the measures is nominal. So click analyzed, non-parametric, and one sample. So it's a t-test for one sample. And of course, initially, so let's reset this first so that then let's repeat the procedure. Analyzed, non-parametric, one sample, so that you're going to see what we have here by default. So we have here, of course, the windows showing us the objective, the field, and the setting. We can actually run it as is, but just to see that, as mentioned, we also need to consider the test that mentions while back. So we will not be running it, but we will be doing some other things first. Like for instance, so we have here the preference menu placed in our test field. And let's see the settings also. For the settings, we will customize the test. And we know that we're going to use binomial test. So we have to check, compare, observe binary or probability to hypothesize binomial test and the options. So by default, the hypothesized proportion is 0.5, which means that we are telling that 50% of the customer will prefer the new menu. So that is what we are telling here. But later, if you have some related studies, related literatures, later indicating the percent or the population percent of a particular particular variables that you want to work on, just like here in the binomial, so you can also set it here. So let's say if it's 75, claiming that the preference of choosing, for example, a movie, watching comedy, for instance, versus a drama, So you can set here, for example, if it's 75%. So, but by default, as mentioned, it is set into 50%, so it is 0.5. So we mentioned Clopper-Pearson, which is a test that is very important in interval, 95% interval. So we will be checking this. And as mentioned, we have to define the success. So it's a default here that we will be using the first category as the success. So that's why we place 1. But just in case that we are, of course, changing this, like for example, we set the success into the second category or 2, so we can specify the success values here. But since number 1 corresponds to our success, then it's okay to just use the default. And then click OK, and we are now set to run our data. So this is the hypothesis test summary showing that we have, of course, a probability of 0.5 and 0.5, and we use one sample binomial test. The significance is 0.1, and the decision is to retain the null hypothesis. Of course, to further see more information about the test, we have to click this table, right-click, edit content in the separate window, so that we will, of course, see in the model viewer other informations that we need. So we have here initially the graph of our observed and hypothesized. So as mentioned, we set it into 50-50. The total n here corresponds to the number of respondents. So we have 30 respondents. Test is statistics 20, which means 20 out of 30 chose the success, which is the new. So we also have here the standard error, standard test statistics, and of course the asymptotic significance or the two-sided. So we know that this is greater than 0.05. It's greater than 0.05, meaning to say that we are going to reject our null hypothesis. We're going to accept our null hypothesis, and it's actually indicated here. Okay, so moving on, we can also consider other information aside from that by, of course, highlighting the use of our confidence interval summary. This one, the Clopper-Pearson. So as indicated, so we have here one sample binomial success rate using Clopper-Pearson. The parameter is probability. The preference menu is equal to new, which is the success. The estimate is 0.667, or this means that 66.7% check, of course, or chose the success. And in the 95 confidence interval, it is also indicating that this is the minimum and 0.827 is, of course, the maximum. So it is telling us that 47, the minimum customer who will choose the new menu or the spaghetti in style, longganisa pasta style, is 47.2%, and the maximum is 82.7%. So in our data, it is 66.7%, or that is, of course, 20, as also indicated in our test test statistics. So we can also see here in our figure. Let's just clear all this drawing. We can also see here in our figure, the observed is 67% for new and the traditional is 33%. So as mentioned, 66.7% or 67% when we round that into whole number. So this is all for this video. Thank you for watching.